Hey, Kenzie, come get these other days in case it snows. I always pick them up so that you pick them up. There you go. Alright, so the stuff we're looking at today is we'll start off with one that's not a word problem, but then they're going to be word problems that get us to a quadratic. So we're going to have to do stuff that we've done in the past with word problems to get them to the quadratics that we worked on solving yesterday. This first one's just a plain old fraction problem. It says 4 over x minus 1 plus 9 is equal to negative 7 over x. And we've solved problems like this. We had a whole unit on solving rational expressions where they had fractions in them, rational equations where they had fractions in them. What makes this one different is that when we get ready to solve it, it's going to end up being a squared, being a quadratic, and we'll have to use the quadratic formula. Okay, but our first task and dilemma is going to be to get rid of those fractions on bottom. Like we talked about before, if I had a fraction, two fractions that had a 2 and a 3 on bottom, their common denominator would be 6 because I would just take the product. I would multiply 2 times 3. So same thing here. The common denominator on this is going to be the product of x minus 1 and x. So that's what I'm going to multiply that whole fraction by. Now I don't want to distribute it because then it'll be harder to tell its parts. I like to keep it broken down in its parts, x and x minus 1. Okay, so now we're going to distribute that to the whole thing. And when I take it to this first 4 here, when I go and distribute there, that 4 had an x minus 1 on bottom, so it cancels that other x minus 1 out, and all that's left is an x, so that'll be 4x. Remember, we've done this before. When I go to the 9, there's nothing to cancel out, so the 9 has to get the x and the x minus 1. And then here when I go to the negative 7, the x on bottom will cancel out, but it still has to get the x minus 1. Okay, so that was first dilemma, was we got rid of the stinking fractions. Now you've got some simplifying and distributing and cleaning up to do. So if you look at that right here, you know you're going to have to distribute. So that's 4x plus 9x squared minus 9x. Over here, that's negative 7x plus 7. That's a squared on that 9x that looks like a bird. Then you got some like terms, 4x and negative 9x right there. So that's 9x squared minus 5x equals negative 7x plus 7. Now, you're pretty good right there. You've got it all distributed and cleaned up best you can, but you notice now you've got a quadratic, and you got 9s and 5s and 7s there, not anything that's real friendly to factors, so you're probably thinking quadratic formula, but it's not ready. So now you got to start moving stuff over to get it in standard form to get it ready. So I'm going to add 7x to both sides, and then I'm going to subtract 7 from both sides so that I've got it set it equal to 0. So when I add 7x, negative 5x and 7x is 2x. And then I got my minus 7 because I subtracted that 7 over. Now we had to do all that work to get it to where the problem started yesterday. So we know now our A is 9, our B is 2, and our C is negative 7. Okay, plug that into the quadratic formula and finish it. Go. do we end up with?
-1 and 7/9.
Okay. Anybody need help there? Did you get Grace? All right, now, next couple are going to come out of a word problem. And I'm going to do the most common type that we always see on our tests, the ones where we're going like upstream and downstream, and then the ones where you're working with somebody, how long does it take you to complete the job, all that kind of stuff. So this first one we got, Kai is rowing his boat upriver and downriver. So I know I'm going to have an upstream and a downstream. I know, and we talked about this when we did these problems earlier in the year, this is always going to be involving our distance equals rate times time formula. So my problem here says in 1 3/4 hour, Kai rows his boat 5 miles upriver and then comes back. So Kai's distance both upriver and downriver is 5 miles. Okay. Then it says the speed of the current is 3 miles an hour. So when he's going upstream, he's rowing against that current, so it's taking his speed and it's slowing him down 3 miles an hour. So it'll be his speed minus 3. Then when he comes downstream, the current's pushing him, he's going faster, so it takes his speed and speeds him up 3 miles an hour. Now if we look over there at our little equation, distance equals rate times time, we know that time would be distance divided by rate. So I would have 5 divided by x minus 3. And here, 5 divided by x plus 3. Now, depending on what the problem says is what you do with those times now. This problem said it took Kai 1 3/4 hours for this trip. So I took the 1 3/4 and I rewrote that as 7/4. So his upstream plus his downstream had to equal 7/4, because that's how long his total trip took. So now we're to where the last problem started. We got to clear fractions out. So we're going to multiply this whole thing by x minus 3, x plus 3, and 4, because those were the 3 fraction denominators that we had. The easy way to think about it, when you distribute these 3 to each of these pieces, if it was already on bottom, it cancels out and it gets the other 2. So this first 5 had the x minus 3, so I don't worry about it, but it gets the x plus 3 and the 4. Okay, the second 5, bless you, had the x plus 3, so I don't worry about it, but it needs the x minus 3 and the 4. And then the 7, it only lost the 4, so it gets the x plus 3 and the x minus 3. It's the x minus 3 that's jumbled there on the end. Alright, when we start distributing this stuff now, I'm going to do some of this on dry erase board because this hasn't been working good when I try to do both places at once. This is 20 times 4 that I'm distributing there. Right? We can make that jump, so that'll make 20x plus 60 for that first one. Then here, this is 20 times x minus 3. So that'll make 20x minus 60. Here, you can write this out and FOIL it if you want to. X plus 3 times x minus 3. That's the difference of squares. And we've done that 10 gazillion times. It's x squared minus 9. If you don't remember it, FOIL it and check it out. So 7 times x squared minus 9 would be 7x squared minus 63. 7 times 9 is 63. Alright, so you got your 60s and negative 60. That took care of itself. Then a 20x and a 20x. So I need to do one thing to move to get it into standard form. So So we're bringing that 40x over. So that gets me 7x squared plus 40x minus 63. Hey, Andrew, did you have your snow day work too?
Not on me.
Well, it's due today.
Get it.
Oh, okay.
Would it be negative 40?
Yes, thank you. Thank you. You're right. I'm subtracting that 40x. Grace saved us a headache there. Good job, Grace. All right, so we're good there now. And I got an A of 7, a B of negative 40, and a C of negative 63. Now, when you're finishing this one up, that's what you're going to your quadratic formula with. When you're finishing this one up, use some common sense. Remember that this is how fast Kai rows his boat. So if at any point you get a negative answer, that's your dummy answer. Don't mess with that. I think that's what I'm seeing Grace with. Does that look close to what y'all got? Now, I know I'm not even going to mess with the minus one, so don't even worry about that, because 40 minus 58 gives us a negative, and we know we can't row his boat negative. So I've got 40 plus 58, should be 98, divided by 14, and Grace is showing me 7. So what y'all got? So what that means is that in still water, Kai would row 7 miles an hour. So in relationship to our problem, if he's rowing upriver, he'd be rowing 4, because it would slow him down 3. If he's rowing downriver, he'd be rowing 10, because it's speeding him up 3. All right, this next type is my least favorite of the type of word problems. It's the one where Grace can do the job this fast, Kirsten can do the job this fast, how long does it take them to do it together, that kind of problem. And I'm not a fan of them, but the good news is the table sets up the same every single time. So as long as you've got how to set the table up in your notes, you'll be able to fill in the stuff and figure it out. It says 2 chefs are preparing a banquet. One chef could prepare the banquet in 2 hours less time than the other. Together, they complete the job in 5 hours. How long would it take the faster chef if he had to do it alone? Okay, so our table we're going to look at, I'm going to have the slower chef and the faster chef, and you could name them whatever you wanted to. Now, on this, we're going to deal with the rate, how fast they work, how long it takes them together. So I call that just together. I'm going to put TOG there for together. And then the part of the job they got done. So I'll put job done. And it's their individual parts. Alright, so what we know, let me read to you again. It says together they can complete the job in 5 hours. So that's going to go in both of them's together column. 5 and 5 right there. Other thing that we know is that the faster chef can do it 2 hours less than the slower chef. But here's where it gets tricky. How fast does the slower chef go? We don't know. We got a variable there. But a complete job done, and this is key for you anytime you're working these types of problems, that means the job's 100% done, which would be 1. So the slower guy would be 1 divided by x. Now the faster guy, he can take 2 hours off that time, so he's 1 divided by x minus 2. And then if you know how fast and you know how long, to figure out how much you got done, you just multiply. So 1 over x times 5 would be 5 over x. And 1 over x minus 2 times 5 would be 5 over x minus 2. Now I just told you what this is going to get set equal to when we add these two jobs. The slower guy, 5 over x, plus the faster guy, 5 over x minus 2, is equal to the total complete job, 100%, which is 1. Okay, so we're going to multiply here by x and x minus 2. So with that first 5, the x will cancel out, so it'll get the x minus 2. With that second 5, the x minus 2 will cancel out, so it'll get the x. With the 1, nothing cancels out, but 1, you don't have to write it again, because 1 times anything is what you started with, so it'll just be that. Alright, so start. That's the hard part. You've got your table deciphered, you got rid of your fractions, now you're just trying to clean it up and simplify it so that you can find a quadratic in standard form. So I've got 5x minus 10 there when I start distributing, plus 5x equals x squared minus 2x. So combine those like terms. 10x minus 10 is equal to x squared minus 2x. Now right here you've got options, and this morning I did it different than some other people, and you could still get the same answer. My personal preference is I like my squared, my a to be positive, so I kept this stuff here and I moved this stuff over. I had some people do it the other way, and that's okay, it'll work. I just like my a to be positive. I'm weird like that. So I did this. I had x squared minus 12x plus 10 is equal to 0. So there's your A, 1, B, negative 12, and C, 10. So see if you can finish that off and figure out how long it would take the slower chef to get the job done. You get two answers, but one of them should not make sense when you use some common sense and put it in context of the problem, and it's not because it's negative either. Yo.
Can you send Kaylee Anderson to check out, please?
Yes, ma'am.
Thank you.
What's the square root of 104? You didn't do that yet. Yeah, so you're going to have a decimal negative. So we'll say 10.20. Alright, underneath the radical, this time you ended up with 104. 104 is not a perfect square, and normally when we do that in class, we have to leave it in radical form. But using common sense, making an implication to this problem, if one chef cooks whatever in square root of 42, what does that mean? So you do get to go ahead and put a decimal on this one. So notice subtracting is not going to get you a negative, so you do need to work both of them out. 12 plus 10.2 be 22.2 divided by 2 be 11.1.
Have a good rest of the day.
You too, Kaylee. Thank you, sweetie. 12 minus 10.2 be 1.8. Should be 0.9. So remember what our x stood for in our original problem was how fast the slower chef could do the job by itself. Which one of those can it not be? How long did it take them to do the job together? Grace is right. It took 5 hours to do it together. So if it took them 5 hours working together, there's no way a slow dude can do it in less than an hour by itself, right? So this one's out. It would take him 11.1 by itself. Which then you could say that means the faster one, it would take him 9.1. Alright. This one, not a word problem this time. We got 2x is equal to the square root of x plus 1, and our directions just say to solve. The dilemma with this one is it's got that radical, the square root. So what we're going to look at on this is we need to do what we call isolate the radical, get the square root all by itself. So we're going to get rid of that extra junk first. So we take 1 away from both sides. Now you can't subtract it there, so you just leave it as 2x minus 1 is equal to the square root of x. Okay, now you're trying to solve for x. Hey,
Update.
okay. Now you're trying to solve for x, but we got a square root of x. So what does it make sense to do to undo a square root? Square it out of kid. But we got to square the whole thing like Rachel knows. Now be real careful. Some people first period mess this up. This doesn't mean 4x squared minus 1. It means you got to write that twice and FOIL it. Okay, so I'll do that up here real fast. 2x minus 1, 2x minus 1. There's your 4x squared. They had that part right. Here's what they missed. Negative 2x and negative 2x is negative 4x. And then there's your plus 1. Here, the squared and square root canceled out. That's what Rachel was hitting at. So it's just x. So you got your quadratic now, but it's not in standard form. What can I do to get that in standard form? Subtract that x. Negative 4x minus x is negative 5x. Almost thought that would factor, but I don't think it does. Factors a 4 that added negative. Oh, wait a minute. It had to be by grouping, though. I don't want to do grouping. So our A is 4. B is negative 5. C is 1. Finish that one out. X equals negative B plus minus the square root square minus 4 AC. Oh, over to you, Rick. Did you get 9 under your radical, Rachel?
I just put it all together and some errors.
Huh. Let's see what you were doing.
Oh, no, I'm not typing it wrong. I'm not putting that negative on this, but,
Yeah, when you do, well, no. That's,
oh, wait, I know I did wrong. I emphasize this for,
oh, yeah.
there we go. There we go.
Yeah, so that's good. All right, so you end up getting square root of 9, which Rachel already had down to 3. So I've got 5 plus 3 divided by 8, and 5 minus 3 divided by 8. 5 plus 3 is 8. 8 divided by 8 will get you 1. 5 minus 3 is 2. So 2 divided by 8. So fourth. Is that what you got, GT? Good job. Alright, I want to show you this last one real quick. Alright, I got 9x to the 4th minus 37x squared plus 4 is equal to 0. We did this a long time ago at the beginning of the year. What's changed is it's not a squared right now, it's a 4th. So what we have to do to use the quadratic formula, it's not called a quartic formula or whatever that is. It's called the quadratic formula. So we have to know that x to the 4th is the same as x squared squared. Right? Because that 2 times 2 would get you a 4 on that. So I can rewrite this as 9x squared I got to make sure I do that so I don't square the 9 also. Then you still got all the rest of the stuff. Now what you're going to do, and we did this a long time ago, it's a pain, but every now and then you've got it. You've got to assign some random letter. X, Y, Q, T, W. I'm going to choose W. W for right now is going to be my x squared. So everywhere I've got an x squared, I'm going to put a W in. Okay? So right here, this x squared, this becomes W, and then it still had that squared out there. So minus 37, that x squared is W. So what that does now is it lets you work it using the quadratic formula. Then when we get our answers in a minute, we'll have to go back and make a little bit of a modification. But our A here is 9. Our B is negative 37. And our C is 4. So it's the same now that we've got that. So 37 plus or minus the square root of, what's 37 squared? Let's do this one. 1369 minus 4 times 9 times 4 all over 18. Make you nervous when I'm watching over your shoulder. 1225, you're doing good. 37 plus or minus the square root of 1225. And then that square root was 35. So 37 plus 35 divided by 18. And 37 minus 35 divided by 18. Okay, what do we... 272 divided by 18 is 4. And then 2 divided by 18 is 1/9. Alright, so that's really, I need to write this, that's really what my W's are. Right? So we made a statement way up here above that W is equal to x squared. So 4 is equal to x squared, and 1/9 is equal to x squared. This is that last modification I was talking about. So to undo this squared, you got a square root. So what's the square root of 4? And there's 2 answers. Very good. 2 and negative 2. You put plus minus 2. What's the square root of 1/9? Square root of the top, square root of the bottom. You got two answers. Square root of 1's 1. What's the square root of 9?
81.
Other way. 3. So 1/3 and negative 1/3. Why did we have 4 answers on this one? Because the original problem started off to the 4th power. Don't see those very often, but just wanted you to remember we did do that a long time ago, so you'll remember what to do if you see it again. All right? Solving quadratics, fun, fun, fun. All righty. Be a wrap. You are fixing to have an éxito question. I'm going to write it up there before I type it in the thing. I'm just going to type it in the thing first.
Exit question.
Yeah, but that's.
All right, that's just got 2 answers. Undo the squares, your first attempt. Alright, it's in my spot, so you might need to refresh yours.